Hello boys and girls. So finally we come to the last part of our tutorial 10. So we are going to discuss on 10.5 Doppler Effect. So have you ever experienced this? You notice that there is a change in the pitch of a bearing horn on a fast moving car as it passes you. So when a source of sound is moving towards an observer, we notice that the pitch the observer hears is higher than the frequency of the sound source. Same goes for when the source is traveling away from the observer, we notice that the pitch will become lower. Okay, so this phenomenon is what we call Doppler effect. Doppler effect can occur for all types of wave. So, how we define Doppler effect? Doppler effect is defined as the change in the apparent or observed frequency of a wave as a result of relative motion between the source and the observer. It means that the keyword for Doppler effect is relative motion. When there is a relative motion between the source and the observer, then we will get what we call Doppler effect, the change in the observed frequency. So, basically, in Doppler effect, we have source and also observer. Source is represented by capital S. Source is the one that going to emit the sound waves. Okay, as shown in the figure below, source is the one that are going to emit the sound wave. Alright. The sound wave that emit will have certain velocity, move with certain velocity, and they might have frequency and also wavelength lambda. Basically, the speed of the sound is remain constant for a same medium. And then we also have an observer. Observer is represented by O. Observer is the one who are going to observe, detect, or hear the sound wave. Alright, observer is the one that going to detect or hear the sound wave. So when there is no relative motion between the source and the observer, all observer will hear the same frequency. Why? Because when the source is stationary, the observer is stationary, we will find out that the distance between them are maintained constant. So the distance between the observer and the source is maintained constant. So means that our wavelength is always the same. So if our wavelength is always the same, our speed is constant, so our frequency will remain the same. So when there is no relative motion between source and observer, we will hear the same frequency. Means that the sound of the same pitch. Okay? So when do we use Doppler effect? When there is a relative motion. So when there is a relative motion, there will be a change in the distance between the source and the observer. Then we will find out that there will be a change in the frequency that we hear. So at that time, we are going to use Doppler effect. Okay. Movement of source will alter the wavelength and the received frequency of the sound, even though the source frequency and the sound velocity are unchanged. For example, I have a moving source, then I have two stationary observers, one standing on the left hand side, one standing on the right hand side. So from velocity equal to f lambda, our velocity or the speed of the sound is always constant. So we find out that our frequency is inversely proportional to the wavelength. Our frequency is inversely proportional to the wavelength. So let us see. For the stationary observer on the left-hand side, as the source moves away from the observer, as the source moves away from this observer, the same number of wavelengths are being expanded in a larger distance. See, the distance between the stationary observer and the moving source is larger. So, our wavelength is expanded to fill a larger distance. So, the wavelength increase. So, when wavelength increase, our frequency will decrease. Why? Inversely proportional. Inversely proportional. So, when our wavelength increase, our frequency will decrease. So, for this observer, it will hear a sound of lower frequency or low pitch when the source is moving away from it. Alright. Then what about the stationary observer on our right hand side? So you will notice that the moving source is approaching this stationary observer. The moving source is approaching this stationary observer. So as the source approaching this observer, the same number of wavelength is being compressed. Why? Because the distance between the moving source and the stationary observer is getting smaller and smaller. So the wavelength is being compressed. Okay, our wavelength is being compressed in a small distance. So our wavelength will become shorter. So again, we refer to the relation between frequency and wavelength. As our wavelength now become shorter, then our frequency will become larger. So, as a result, for this stationary observer, it will notice that it will hear a sound of higher frequency or higher pitch when the source is moving, approaching this stationary observer. So this is what we call Doppler effect. When the source is moving away, we hear the lower frequency, lower pitch. When the source is approaching us, approaching, then we will hear the sound of higher frequency, high pitch. So, the general equation we use to calculate apparent frequency is given by Fa equal to, in bracket, V plus minus VO over V minus plus Vs multiplied F. V is referred to the speed of the sound. V subscript S referred to the speed of our source. V subscript O is referred to the speed of the observer. F subscript A is referred to the apparent frequency or observed frequency. It means that the frequency that we hear. F refers to the frequency of the source, or we call it as the actual frequency that emitted by the source of the sound. Okay. So if you notice that we have plus minus sign for speed of the observer and also plus minus sign for the speed of the source. So how to determine the correct plus or minus sign in the general equation into various situations? So we are going to use the method OS. Okay. So I'll show you once how we are going to get the correct equation for a specific situation from a general equation given. So for example, I have a moving observer approaching a stationary source. So the source that emits the sound is stationary, and then I have a moving observer approaching this stationary source. So how I'm going to get the correct plus or minus sign for velocity or speed of the observer? So refer to the general equation. From the general equation, this one. So how I'm going to get the correct sign, plus or minus, for these situations? So I'm going to use OS. So we notice that our observer is approaching the source. So I draw from the observer, towards the source. I draw from the observer towards the source. So I'll get a plus sign. So I'll get a plus sign for the speed of the observer. The speed of the observer. Alright. So if this is our general equation, it will means that my speed of the source is 0 because stationary source. So I'll throw out this one. Because it's 0. And then my moving observer is approaching the source. I use OS method. I get plus sign. So I'll throw away the negative sign. So this will be the equation for this specific situation in order to calculate the apparent frequency or the observed frequency here by the observer. Clear? On how to choose the correct sign, plus minus, from the general equation. This is how we choose. We are using the OS method. Alright, so we will notice that our frequency is changes as the source is approaches or moving away. So we might plot graph frequency against distance travel. So as the source moves closer, approaches the observer, we notice that our apparent frequency always larger than the actual frequency. So we have this one. Our apparent frequency when the source is approaches is higher than the actual frequency. At the moment where the source crosses the observer, we will find out that our apparent frequency will equal to the actual frequency. So means that the observer will hear the actual frequency. As the source moves away, if our source is moved away from the observer, then at that moment we will find out that our apparent frequency will be less than the actual frequency. Okay, so this one, for moving away, our apparent frequency will be less than our actual frequency. So this is the pattern or the shape of the graph if we plot apparent frequency against distance travel. So now class, let us try solve question 14 and 15 in tutorial 10, applying the concept we already discussed just now about the Doppler effect.